here. And this is just another format of a similar type of program, but this one focuses on case studies. And so here we have to moderate and also to present on case studies, the benefits of case studies and types of case studies you can consider, is Lori Blair. Lori Blair joins us from Ericsson today. We will also have presentation by Chris Wixom with Corning Optical Communications, and Robin Gamble, who is the founder and CEO of Persistent Telecom. So without further ado, I'll hand it over to Lori. Thank you.
Thanks, Alyssa. So before we get started today in talking about mobile solutions and technology to enable the Internet of Everywhere, as Alyssa said, I'm going to spend just a few minutes talking about some of the market drivers as we're solving for mobile technology trends, and essentially what is the big picture that we're solving for. So first of all, let's take a look at the mobile data traffic growth. In large part, this is attributed to the number of mobile subscribers, which is expected to reach 9.1 billion by 2021. And with that is the increase in traffic on the smartphone devices, which will be 11 times increase by 2021. Much of this data traffic will be coming from video, expected to be 70%. So let's take a closer look at that. Media is going mobile and increasingly on demand. By 2014, mobile share of video plays had reached 40%, and watching on demand had outpaced broadcast TV. We have here some data from ESPN and HBO. And as a for instance, how many of you are regularly watching sporting events from your mobile devices? A show of hands. Okay, some of you, perhaps most recently the March Madness games. So suffice it to say, users want to access their favorite content anytime and anywhere. This is putting great capacity demands on the networks that mobile technology will need to solve for. Additionally, we need to keep in mind the enterprise trends and the great ICT transformation. 80% of enterprises will adopt a software as a service model by 2021, and 70% of companies will run their infrastructure in the cloud. Businesses need their employees to have access to business systems and applications regardless of where they are. How many of you here today have been conducting business from your mobile device? I'm sure everyone in this room. Yes. So just imagine once we have even more access to business critical applications, how productive we can be. CIOs and CTOs are understanding this, and 7 out of 10 believe mobility to be mission critical for their business. And lastly, we must keep in mind the massive IoT applications coming our way, which is expected to be billions of devices needing connectivity. I'm not sure if you can see here, but we have some examples of industries who will be using IoT applications. Everything from smart buildings to healthcare, transportation, utilities, and energy. And no single technology will be able to address all of these applications, but rather a family of technologies working complementary together. And certainly LTE technology will be able to provide vital capacity needed to meet these use cases. So let's talk briefly about the importance of having case studies, particularly as we roll out new technologies. Customers inevitably want to know who else is using this solution. What can I expect during the deployment? What are the real-life performance results? I don't know how many of you have these types of questions posed to you before your customer is ready to spend their money. So now I'm going to talk about some different examples of types of reference cases and proof points that can be used to address these types of inquiries with the users and the customers. So here we have a reference case for performance. In this situation, we were comparing the performance inside of a building with the outdoor network alone, as opposed to once an indoor solution was deployed. In this situation, there was a 10 times improvement in the throughput. going from 3.3 megabits per second to over 60 megabits per second. As the capacity demands grow in the networks, it will be imperative to be able to document performance results of the solutions. Here we have an example of a proof point for installation and deployment. Customers want to know, what can I expect during the deployment timeline? How quickly can this solution be on air? So this is an example of demonstrating the installation timeframe for various components of this solution. Now we have an example of an enterprise reference case in which we're detailing the size and location of the building. What was the coverage scenario? How many devices were installed for what types of bands? And what was the performance achieved? Again, to help document what was the real-life expectation with this solution. And lastly, customers want to know, where has this solution been deployed? Who else is using this solution? So this is an example of noting globally where a solution is installed, how many operators are using the solution, and various comments on some key projects. So again, just to give you an idea of some examples. And suffice it to say, a lot of demand will be put on mobile technology, and as solution providers, it's important that we document the reference cases for potential customers. And with that, I'm going to turn it over to Chris Whitson from Corning, who's going to go into detail about providing the Internet of Everywhere at Texas A&M Stadium.
Thanks, Lori. So as Lori is mentioning, I'm going to talk a little bit about Texas A&M. It is a great example of putting in a solution of trying to support the Internet of Everywhere. How do you support all the various things that you're going to be doing in either a stadium or other verticals as well? So we'll talk a little bit about that. Texas A&M, what is it? It's the third largest stadium in the country. It has about 104,000 seats in it. At maximum capacity, it's about 110,000 people. Very, very large site. This was an interesting challenge because when they were building this out, they actually took the old stadium and they blew up half of it and then built up the new stadium for half of it. And then the next year, they blew up the second half of it and built it other. So you can imagine putting in a system where you're only supporting half the stadium initially, and then replacing it a year later created a lot of challenges. So let's talk about what the challenges were and what we did. From a Internet of Everywhere, what does that mean? What are we trying to support? Well, first of all, you have back of the house. Back of the house is a variety of different things. We had almost 1,400 Wi-Fi devices supporting the Wi-Fi throughout the stadium. You also had your LAN-based systems, you had your IP telephony, and other types of things, all needed to be supported by a system of some sort. In addition to the back of the house, you had the operations side. So how do you do this? And this, again, this goes for a stadium. It also goes for a high-rise or a healthcare or hospitality. You all have these types of challenges. How do I support my operations and security, both from my building automation, my cameras, and my security? In the stadium case, I've got 110,000 people coming in. How do I do wireless ticketing and manage all of that end, and then also manage my building automation? And then finally, we've been talking a lot today about the fan experience. How do I make sure that I've got the right capacity, the right coverage, not only for my mobile phones, but also for my Wi-Fi? And then how do I make sure that I take good care of the folks in the suites? So in this particular case, they had 350 or so high-definition TVs in the suites. What do I do with that? How do I support it? And then not only what network do I have, but what applications do I want to put over this network with video playback, with ordering in your seats, and those types of things. So as you take all these challenges, what are some of the decisions that you need to make? Who do I partner with? Do I buy it myself? Do I have a carrier lead it? Do I work with the integrators, or do I work with a tower team company? How do I manage all this? Do I do a parallel approach? with multiple technologies, or do I try and do an integrated approach and put it all over one system? These are some of the challenges that you need to look at, and what we're going to talk about is what Texas A&M decided to do, and then we're going to go into what were the results. So Texas A&M in this particular case decided to work with an integrator. They decided to purchase the equipment themselves and work through the integrator, who was IBM. They decided to go with an integrated approach instead of doing multiple parallel layers, and they decided to use the Corning One platform. Corning One is an all-fiber-based architecture where you can put basically anything IP related over this infrastructure. So all of these things up here, whether it be your point-of-sale systems, your Wi-Fi systems, your carrier cellular systems, all of that can be put over a single infrastructure. And that leads to a lot of cost savings, a lot of efficiencies, a lot of space savings and power savings and those types of things. The other thing that they decided to do, which is actually very critical, was instead of doing a traditional packet switch network, they decided to go with a PON-based system. Now, PON has been used all over the world and is traditionally done for video to the home and those types of things with Fios and other types of technologies, but it hasn't been used as much in buildings. So this was something relatively new that really hasn't been done before. With the PON architecture, it does two things. One, because it's a broadcast architecture, it gets rid of all the switching equipment in the middle. Frees up a lot of telecom space, frees up a lot of cost savings because you're not doing a lot of cooling and powering of that equipment in the telecom and the IDF. And because you're not doing a packet switch approach, you can guarantee bandwidth. So 110,000 users, to guarantee bandwidth to those 110,000 users would be very, very difficult. With a PON approach, you can guarantee it and get very, very strong service. Over in the corner, so if you can picture it, you've got fiber going out to all of these zone boxes out in these remote areas. We have a couple of things in there. One, we have the active cellular equipment, and then two, we have what are called ONTs, which provide the IP ports for your various things that you're going to attach to it. So off of those ONT ports, you would attach your POS or your Wi-Fi APs or those types of things. So what were the results? So significant cost reductions, not just because you're doing everything over a single architecture, but also because you're doing this PON-based approach. The carriers saw about a 55% reduction in cost, and the Texas A&M saved almost $9 million going from this packet-switched architecture to a PON-based architecture, so significant savings. Network performance, we saw about 5 terabytes of data go through the Wi-Fi system in the first game alone, so tremendous amount of bandwidth going through the Wi-Fi system. And similar on the carrier side, you saw very, very strong KPIs and 2 to 3 terabytes going through the carrier side. As I mentioned earlier, tremendous savings in space. I think we went, if I remember correctly, from multi-million square feet of copper to only like 200,000 square feet of copper. So amazing savings on copper and getting rid of the traditional way of doing things. And then from a power consumption, 80% reduction. It's pretty amazing that you can get that kind of a reduction by getting rid of a lot of the equipment in the IDF. One thing to mention too, with space being of a critical concern, not only in stadiums like this, but also in buildings like this, the head end was removed. We did a remote head end with about 3 miles away, where all the carrier equipment, the Wi-Fi equipment, and all of that was located. And then the final thing to think about, a lot of the comments today are all about things are changing so fast. Having to look at something with Wi-Fi changing, what was normal 2 years ago is now obsolete. So when building these types of solutions, you want to build something that is flexible, that can adjust very, very quickly with the changes, whether that be sectorization changes, whether that be frequencies and other things that the carriers are going to launch, or technology changes with AP and the APs and those types of things. The one solution, because you've got fiber out to the edge and you've got multiple strands out to the edge, is very, very flexible so that you can adjust as these changes occur instead of having to do a rip and replace. So anyway, we'll take questions later, but a little case study on Texas A&M.
Thank you, Chris. And now we have Robin Gamble with Persistent Telecom, and he's going to give us details of a case study of how Persistent Telecom delivered mobile solutions for their end customer.
Good afternoon. I'm going to talk briefly about sort of a unusual deployment of small cells that goes beyond the traditional connections provided by small cells to include cybersecurity, BYOD, policy enforcement, continuation of operations, which is COOP, and continuation of operations, which is we call COG. This story starts in the summer of 2011 when Secretary of Defense Gates was increasingly concerned about the ability for the Defense Department and the intelligence agencies to be able to communicate in a condition of degraded operations. Degraded operations probably for me goes back to New York in 1978 when they had the blackout and we didn't have any phone systems. Then again in 1989, we had the World Series and a San Francisco earthquake. And that was the first time the national grid went down just from call volume, from people picking up too many phones all at the same time. As we've all seen in Katrinas and Sandys and countless other events, the networks go down either from call volume or lack of power. Excuse me. I really enjoyed, well not enjoyed, but I was no surprise to find out that during the last New York blackout, we lost all the central offices because all the batteries were dead. And all the batteries were dead because they had not been replaced since they put them in after the 1978 blackout. If you've ever seen one of these battery farms, it's like 1,000 car batteries in a room. It's an environmental nightmare. So one thing important to understand about defense and intelligence in the United States is, along with guns and knives and chemical weapons and cameras and data sticks, there are no cell phones allowed in agency headquarters. So what we did was we put a distributed cell phone network in the Defense Intelligence Agency headquarters at Bolling Air Force Base and at another office building that they had that was line of sight about 15, 20 miles away. 50 phones were issued in each building to key management personnel. These phones were the only phones that would be allowed to register with the network. And in the case of a failure, unfortunately, our intelligence agencies are all getting all their news these days from CNN and others, which are all coming in over the same fiber that we're anticipating has now crashed due to a cyber attack or an earthquake or who knows what the heck. And these 50 people, their phones would only operate on that network, and that network would only operate in the case of a failure of the commercial networks. We were able to layer another element on there, which was the ability to, since we've already got cell phone sensing going on throughout the building, if anybody were to turn on a phone anywhere in the building, it would send an alert to security that on the 3rd floor of the annex, we have this mobile phone is now activated, or iPad, or whatever type of wireless device. The two buildings were then interconnected with a WiMAX, so that if, well, the admiral that ran it, he always said, every meeting he always said the same thing. On September 11th, we spent all our time in the Pentagon trying to figure out where our people were. And if we got a phone line open to Quantico, we never hung it up the whole day. We just laid it down on the counter. So in this case, because the two private networks were joined together by Wi-Fi, I just had to dial your cell phone, and I could find out where you were and what personnel were there, regardless if you were in the office building or you were in the main agency headquarters. We then also enabled both of them with satellite connection on the roof to support 50 simultaneous phone calls from either building in case one of the buildings wasn't there, and the satellites terminated at a teleport out in Colorado. In this case, if Colorado was up, then they would have access to the internet, or they'd be able to send text messages or call the guy from the Center for Disease Control at the University of Michigan that would be the specialist in that type of area. So I guess the message is as small cell becomes deployed in the enterprise and in public safety and large event places like Texas A&M, it gives you actually the control to put other policies and practices and procedures in place right at that site. So, you know, I remember very clearly how the lights all went out at Giant Stadium, you know, and probably 400 FBI agents were, you know, looking for snipers somewhere. In that case, because you have the small cell network and you have control of it, you can broadcast text to all those people without being dependent on a commercial carrier. We did a project years ago for a tobacco company. I don't know, anybody ever have a Trio? They wanted a Trio with no camera. So Palm employed us to delete the camera software and to neuter the camera hardware so that the people could BYOD into this tobacco company, but they wouldn't be taking any photos for 60 minutes. So just something to think about, that the advantage of small cell goes beyond the reliance on the back end coming from the carrier, that you can have local processing that could serve all kinds of different other applications. Thanks.
Thank you, Robin. So indeed, some interesting case studies on how different providers are solving for mobile technology solutions. So I'll kick off the questions with a couple, and then we'll open it up to the audience and see what all questions you have. Chris, I'll start with you. So in combining all these different services onto one platform, were there challenges getting all of the various stakeholders, for instance, the cellular carriers and the Wi-Fi stakeholders, all to the table in an agreement in how this would all work out?
No, not at all. Yeah, it gets to be very, very tricky, because you imagine in any major building owner, you've got your IT professionals, you've got your cellular professionals, you've got different groups running each of these various services. You probably have your own security as well. And so you really need a centralized force at the very, very high levels within an organization to drive these different teams to work together. Otherwise, you end up seeing these parallel approaches be put in. In our particular case, we had the provost driving this kind of integrated approach. Otherwise, I don't think it would have happened.
Yeah, that's an interesting point. I know in one of the sessions this morning, talking about stadiums and arenas and the different business cases, and determining, does the stadium decide we're going to spend our money because we have the ROI in the business case to do so? It sounds like Texas A&M made that decision, and with that, they were able to have more control as well. Would you say that's accurate?
Oh yeah, absolutely. And in their particular case, they saved a lot of money because they had budget based on a packet-switched AP wireless network. And because they went from this packet-switched approach to a PON-based approach, they saved a lot of money, and therefore they had a lot more budget than they expected.
So that leads to a good next question. So tell us more about PON, and how do you determine to incorporate the PON solution or not with this type of, with the one technology?
So just, most people know about PON in the room? Okay, so for those of you that have not been exposed to PON, PON is, as I was mentioning earlier, been deployed for years for the Verizon Fios network and those types of things. The main difference between PON is it is a passive network. You are doing a broadcast and having device at the edge of the network to decide where a video or a packet goes to, instead of having an active switching device sitting in your IDF. So it gets rid of a ton of equipment that you would normally have and puts devices out at the edge called these ONTs. What was the question? Oh,
So determining
when
to
do you
use
determine?
PON, when to use PON.
So in my mind, PON networks drive a significant savings for building owners and when you're doing these types of things. However, PON is not well adopted. And so we very quickly determine the kind of barometer of, or temperature gauge of whether somebody's willing to accept a PON technology or not. And we will flip over and offer a packet switch network based on one or a PON-based solution, depending really on where the technologists are and where their mind's at. Some people are not ready to accept it yet.
Okay, great, thank you. So I'll open it up to our audience. Does anyone have any questions for Chris or Robin this time? Ray?
Hey, Chris. Ray Hill.
Do we need a microphone? There's a microphone a little bit, about halfway back.
So, Ray Hill. Good presentation.
I'm sorry, what was your name?
My name is not Chris Wixom. So, Chris, question for you. So, when you look at PON versus packet, and you look at the stadium versus the Tier 2 versus the Tier 3 buildings, where do you see, and IP, right, convergence onto IP, how do you scale this into the Tier 2, the 200,000 square foot building, the 300-bed hospital? What kind of feedback are you guys getting with those types of venues?
So as I said, so very good question, thank you, Ray. Definitely, it's a question of readiness to adopt the technology first, and then secondly, in a smaller venue where you may not have the need for that middle switching equipment, then you don't get the savings that you might in a large deployment like a stadium. The other thing is it's not all just based on cost, it's based on performance. So it is very, very difficult to get the kind of throughput that you need when you have 110,000 people all trying to jump on, because you get backups, traffic jams on the switching gear. So the real benefit of Texas A&M is that now I've got guaranteed bandwidth for 110,000 people. It's pretty amazing, actually, and a consistent experience for that fan, no matter where you are. It's pretty neat.
So I have a question over here.
Yeah, Robin, can you compare or contrast your small cell implementation at the DIA to like a typical enterprise small cell implementation?
The real difference between our small cell application and the traditional small cell application is that we built a software platform that puts all the processing of the cell phone network on a single computer. And so this means that rather in a traditional, the DAS is connected to regular telephone gear, standard commercial gear in a room, a lot of power, a lot of heat, and then it goes into the carrier in the traditional cell carrier format. But the way our platform works is we've written a software core that performs all the services that would normally be done in a rack of gear inside Ma Bell, if you will. And so that means that we have a mobile switching center and a base station controller and an SMSC and GPRS and Edge and LTE, and all those functions are being performed on a single computer. And then if you want to go to another location, whether it's Wi-Fi or fiber or satellite off the two buildings, we're just shipping IP. So basically what we've done is we've moved the computing and the processing right out to the small cell itself. And that's what makes it sustainable. So if the other building were to no longer exist, they're not dependent on some sort of core in some other location. Or if the connectivity were to go down due to a cyber attack, we're not dependent on being able to get into the network operating center. We can still, all the people on site still have comms, still have text. They just can't hit the outside world. I don't know if that answers what.
No, it's a very good description. Thank you.
Yes, sir. Thanks.
Good question, thank you. Does anyone else have any questions for our panelists? Okay, well, we started it a little early, so I guess that means we can wrap up a little early as well, and I think we have a break coming up.
I have a white paper on that, if anybody wanted to look at the white paper.
Great, thank you, Robin. So before we head out for a break, I do want to acknowledge our live stream video here again. Just want to make sure that you understand that there's a little typo on the front page here. It's NEDAS NYC 2016, if you want to pass that on to any of your friends, coworkers, colleagues. And I also want to acknowledge the Internet Society, who is a sponsor of that and helping us stream